Look at this flame. Just a small fire, no bigger than your fingertip, dancing atop a candle in the darkness. You've seen thousands of flames like this in your lifetime. Birthdays, dinners, quiet evenings. Perhaps you've never given it much thought. It's ordinary, commonplace. A simple chemical reaction we learned about in school and promptly forgot. But what if I told you that in this humble flame burns a story that spans the entire history of the universe? What if this small light connects you to the most distant stars, to the violent deaths of ancient suns, to the very birth of time itself? The question, why does fire burn, seems simple. A child might ask it, but the real answer takes us on a journey from the subatomic realm of quantum mechanics, through the cosmic forges of stellar nucleosynthesis, across billions of years of cosmic evolution, and back to this single point of light before you. Every time you strike a match, you are witnessing a reunion of atoms forged in the hearts of dying stars. You are watching ancient sunlight, stored for millions of years in molecular bonds, being released back into the cosmos. You are participating in a process that powered the first human fires and powers our sun at this very instant. The flame is not just burning, it is remembering. It is the universe recalling its own magnificent history. Let me take you on a journey through the physics, chemistry, and cosmic history of fire, and I promise you, when we're done, you'll never look at a flame the same way again. To understand fire, we must first become very small, smaller than a grain of sand, smaller than a cell, smaller even than the wavelength of light itself. We must descend into the realm of molecules and atoms, where the drama of combustion unfolds. What you're seeing is real. As real as your hand or this device, these are molecules of cellulose or hydrocarbons, precise arrangements of carbon, hydrogen, and oxygen atoms locked together by the electromagnetic force. These bonds are strong. They represent valleys in the energy landscape of matter. The atoms have been this way for years, perhaps decades, perhaps millions of years in the case of coal, waiting. And here comes oxygen, molecular oxygen, two atoms bonded together, tumbling through the air, making up 21% of every breath you take. These molecules are in constant thermal motion. At room temperature, wood and oxygen can coexist peacefully for centuries without reacting. The energy barrier between them is too high. Heat provides the energy to overcome that barrier. When you light a candle, the match provides that crucial pulse of thermal energy. And then it begins. When hydrocarbon encounters oxygen at sufficient temperature, something extraordinary happens. The oxygen molecule collides with the hydrocarbon. In that infinitesimal moment, bonds break and new bonds form. Carbon atoms, which had been linked to hydrogen, suddenly find themselves attracted to oxygen with greater force. New molecules emerge, carbon dioxide and water vapor. And in that rearrangement, energy is released. Tremendous energy. This energy had been locked away when the molecules were first assembled. Trees capture photons from the sun through photosynthesis and store that energy in chemical bonds. They're bottling sunlight. When conditions are right, that ancient sunlight is released. The energy that fell on Earth millions of years ago, absorbed by ancient forests and compressed into coal, can be released tonight. You are watching Paleozoic sunlight, but the process sustains itself. The heat from initial reactions provides activation energy for neighboring molecules to react. Those reactions release more heat, triggering more reactions. It's a chain reaction continuing as long as fuel, oxygen, and heat are present. Fire is not a thing. Fire is a process, a verb, not a noun. It's constantly unfolding, a dynamic equilibrium between destruction and creation. Every flame that has ever burned, from the first lightning strike to the fusion reactions powering the sun, is the same fundamental process. Molecules meeting, bonds breaking and forming, energy transforming. And the players in this molecular dance have ancient origins. Those carbon, oxygen, and hydrogen atoms weren't always here on Earth. To understand where they came from, we must travel into deep space and deep time. Consider the carbon atom at the center of a burning molecule. Right now, it's combining with oxygen, releasing light and heat. But where did this carbon come from? Carbon is created in only one place in the universe, in the cores of stars. Imagine a vast cloud of gas in space, mostly hydrogen with some helium. For millions of years, it drifts, slowly contracting under gravity. As it contracts, it heats up. Gravitational potential energy converts to thermal kinetic energy. The temperature climbs. 1 million degrees, 10 million, 15 million. And then ignition. At 15 million degrees, hydrogen atoms have enough kinetic energy to overcome electromagnetic repulsion and fuse. 4 hydrogen nuclei combine to create 1 helium nucleus. A tiny amount of mass converts to energy following Einstein's equation. This is nuclear fusion. This is what makes stars shine. For millions or billions of years, the star burns hydrogen into helium. Fusion pressure balances gravity's pull. But in massive stars, this phase doesn't last long. They exhaust their hydrogen in just millions of years. With no hydrogen left, the core contracts and heats further. At 100 million degrees, helium itself begins to fuse. And here is where carbon is born. 3 helium nuclei combine to create 1 carbon nucleus. This is the triple alpha process, and it works because of a quantum resonance in the carbon nucleus. Without this coincidence, carbon wouldn't exist. No carbon means no organic chemistry, no DNA, no life as we know it. Every carbon atom in your body, your world, your candle was created through this process. But the story continues. As helium exhausts, the core contracts again. Temperature rises to hundreds of millions of degrees. Carbon fuses to create oxygen, neon, magnesium. Oxygen fuses to create silicon. Silicon fuses to create iron. Each stage produces heavier elements. Each releases less energy. Each proceeds faster. Hydrogen burning lasts millions of years. Silicon burning lasts days. And then the star reaches iron. Iron changes everything. Iron is the most stable nucleus. Fusing iron requires energy rather than releasing it. When the core turns to iron, there's no more fuel, no more outward pressure. What happens next occurs in less than a second. The iron core collapses. A sphere the size of Earth compresses to just 20 kilometers across. Material falls inward at a quarter the speed of light. The density becomes incomprehensible. And then it rebounds. The collapse creates a shock wave traveling outward through the star's layers. Everything outside the core is blown into space with unimaginable force. A supernova. For weeks, this single star outshines its entire galaxy. It radiates more energy per second than our sun will produce in its entire lifetime. In that explosion, all the elements created in the star's core scatter into space. Carbon, oxygen, iron, and in the violence itself, even heavier elements form. Gold, platinum, uranium. The star's outer layers billow into space, forming expanding shells of gas and dust. These remnants mix with the interstellar medium, forming molecular clouds where new stars are born. Our sun is such a star, born from a cloud containing not just hydrogen and helium, but carbon, oxygen, iron, all elements created by stars that died before our solar system existed. Earth is made from stellar debris. You are made from stellar debris. Every breath you take, every flame you light is composed of atoms forged in stellar furnaces and expelled in supernovae. We are literally star stuff. The carbon in your cells might have been created 8 billion years ago. It drifted through space for eons, eventually ending up in the cloud that formed our solar system. It cycled through Earth's systems and eventually found its way into you. Every atom has a story spanning the universe's history. So when you look at this flame, understand what you're seeing. The carbon atoms were created in a massive star's core before our sun was born. The oxygen was forged in another stellar giant's final moments. The hydrogen dates to the Big Bang itself, to the first 3 minutes when conditions allowed protons and electrons to form the simplest atom. Every flame is a reunion of stellar ashes. The universe is not just in the flame. The flame is the universe transforming itself, continuing the eternal cycle that began 13.8 billion years ago. But there's still one question. Why does fire glow? To answer this, we must enter quantum mechanics, the physics of the very small, where reality becomes profoundly strange. Picture a carbon atom. At its center, a nucleus of 6 protons and neutrons. Surrounding it, 6 electrons held by electromagnetic attraction. These electrons don't orbit like planets. They exist in specific, discrete energy levels. An electron can be in one level or another, but cannot exist in between. It's like a staircase. You can stand on one floor or another, but cannot float between them. Energy levels are quantized. When combustion occurs, tremendous energy is released. Electrons absorb this energy and jump to higher quantum levels. But these excited states are unstable. Within nanoseconds, the electron falls back to a lower level. And when it falls, it must release that energy as a photon, a quantum of light. This is where the glow comes from. Every photon you see was created by an electron dropping from a higher quantum state to a lower one. Trillions of these transitions happen every second. The color depends on the size of the quantum jump. A candle flame at 1,000 degrees produces mostly orange and yellow photons. A gas flame burns blue, higher energy transitions. The hottest stars glow blue-white. The coolest stars glow red. It's all the same physics. Electrons changing energy states. The photons leaving this flame travel at light speed until they encounter something. Some strike your eye within milliseconds, triggering signals your brain interprets as seeing. Others travel farther into space, potentially journeying for billions of years. Light from ancient stars reaches us after cosmic journeys, and light from your candle begins its own journey tonight. There's beautiful symmetry here. The carbon atom was created by fusion in a star through electron transitions producing light. Now in the flame, that same atom produces light through the same quantum mechanism. The physics powering stars is the same physics lighting your candle. The same rules apply everywhere, and to everything. From the quantum scale to the cosmic web, it's all connected. And in a flame, all scales meet. Quantum transitions create photons. Chemical reactions transform molecules. Gravity and electromagnetism play their roles. Every fundamental force is represented. This is why fire has captivated humanity. Fire is a window into reality itself. But there's one more connection. Fire didn't just illuminate humanity. Fire made humanity. Between 1 and 2 million years ago, our ancestors learned to control fire, not to create it, but to capture it from lightning or volcanoes, to keep it alive, to use it. This was evolution's turning point. Fire provided warmth, allowing survival in cold climates. Fire provided protection from predators. But most importantly, fire gave us cooked food. Cooking is pre-digestion. Heat breaks down cells and proteins. Cooked food releases calories more easily. Our ancestors who ate cooked food could extract more energy from the same amount. Those extra calories could be redirected to larger, more complex brains. The human brain consumes 20% of the body's energy. Some anthropologists argue we couldn't have evolved large brains without fire-cooked food's concentrated nutrition. Fire helped build our minds. Once we mastered fire, we became cosmic engineers. Fire cleared land for agriculture. Fire hardened clay into pottery. Fire transformed ore into metal, copper, bronze, iron, steel. Every civilization leap came through controlled combustion. The Bronze Age, the Iron Age, the Industrial Revolution with coal-powered steam engines transforming society. The modern world still runs on fire, fossil fuels burning in power plants, gasoline in engines. Even space exploration depends on fire. Rocket engines are sophisticated combustion chambers. Fire took us to the moon. We are the species that tamed fire. And in taming fire, we tamed cosmic transformation itself. We learned to liberate solar energy stored in ancient organisms. We learned to transform matter at will. Fire was humanity's first technology, and it's still our most important. When you light a candle, you're participating in a tradition stretching back hundreds of thousands of years to the first maintained fires where humans shared food, told stories, and became human. The power to control fire came from the same source as fire itself, stars. Our brains are made of carbon, oxygen, nitrogen, all stellar elements. We are star stuff that learned to manipulate star stuff to release energy from star stuff. The universe made stars. Stars made elements. Elements made planets. Planets made life. Life made minds. Minds made fire. Fire made civilization. And civilization now explores the universe that made us. It's all connected. One magnificent chain of cosmic evolution. Let me bring this together. Fire burns because atoms forged in dying stars, scattered in supernovae, gathered in a solar nebula, condensed into planets, incorporated into life, and harvested as fuel or finding new, lower energy states. Fire burns because oxygen atoms seek carbon atoms with a molecular attraction billions of years in the making. Fire burns because electrons jump to higher quantum states and fall back down, emitting photons that reach your eyes. Fire burns because thermodynamics demands entropy increase, but in that dispersal, new complexity emerges. Stars, planets, life, minds, civilizations. Fire burns because the universe is not static. It's a process, ever-changing, flowing from the Big Bang into an uncertain future, and we witness one infinitesimal moment. Fire burns because the laws of physics permit it, because forces have the strengths they do, because the universe began with conditions allowing matter to exist, interact, and create complexity. But the deepest answer is this: fire burns because it can. Because the universe is constructed so matter can transform, energy can flow, complexity can emerge, and consciousness can arise to ask why and discover answers spanning cosmic history. The flame is telling a story written in chemistry, physics, and time. A story beginning with the Big Bang, flowing through stellar generations, through our solar system's formation, through life's evolution, through human consciousness, and ending here now with you understanding. Every time you see fire, a candle, a campfire, or the sun itself, remember what you're witnessing. You're seeing matter and energy performing an ancient dance choreographed by fundamental forces. You're seeing stellar ashes recombining, releasing energy held for eons. You're seeing photons born in quantum transitions, beginning journeys lasting microseconds or millennia. You're seeing the same process that powered ancestral caves, cooked first meals, forged first tools, made us human, built civilization, and launched us spaceward. Carl Sagan said, "We are a way for the cosmos to know itself. Fire is a way for the cosmos to remember itself, to recall its stellar birth, to revisit supernova transformations, to celebrate its concentration into planets, life, and minds asking why." The next time you strike a match, remember you are star stuff igniting star stuff to release starlight. You are temporary cosmic awareness, witnessing the universe's endless transformation. And this small flame burns the entire cosmic history. Every atom tells a billion-year story. Every photon begins a journey outlasting civilizations. And in your mind, capable of understanding, capable of asking and answering, burns something equally remarkable: the universe's capacity to know itself, to marvel at itself, to love its own unfolding. The flame is not just burning. It's remembering 13 billion years. It's demonstrating physics from quantum mechanics to thermodynamics. It's connecting you to stars that died before Earth existed. And now, so are you. Remember this: when you light a fire, you're not just creating light and heat. You're participating in the grand cosmic story. You're witnessing universal transformation. You're continuing a tradition from the Big Bang to the unimaginable future. You're lighting a candle and illuminating the connection between all things across all space and time. That's why fire burns. And that's why it matters.